what if an AI could do more than just give you a quick answer? What if it could actually think harder, really pause, reflect, and reason its way to a better solution? Well, a fascinating new paper is out with a revolutionary idea that might just make that a reality.
So, what's AI's biggest blind spot right now? I mean, these models are brilliant at fast, intuitive stuff. Drafting an email, recognizing a face, no problem. But throw a really tough problem at them, one that needs slow, careful reasoning, and they often just fall flat.
This actually taps into a classic idea from psychology you might have heard of: System 1 versus System 2 thinking. System 1 is that gut reaction, right? It's automatic. System 2, well, that's when you have to stop, really focus, and consciously work through a problem step by step.
And here's the thing. This is the core issue. Most of our AI today is built for those quick, System 1 style answers. They're designed to spit out a response in one go. They don't have a way to just pause, reconsider, and do that deeper, more analytical kind of thinking. So, why can't AI learn to think slow? Well, according to this paper, to get to that true System 2 thinking, AI is missing 3 really critical pieces of the puzzle. Okay, this table lays it all out perfectly. Look at the top here. We've got the 3 key abilities for slow thinking. First up, dynamic compute allocation. Basically, the ability to spend more time on a harder problem. Next, modeling uncertainty. That's about knowing when you're not sure about an answer. And finally, prediction verification. This is huge. It's the ability to check your own work. And as you can see, current models, big X on all 3. The goal is to build an AI that can finally tick all these boxes.
So the breakthrough idea here is a really simple but kind of profound shift in how we think about building these systems. Instead of training a model to generate an answer from scratch, what if we just trained it to verify one?
And this whole approach is built on this really powerful principle from complexity theory. The idea is simple. Checking if an answer is right is just way, way easier than coming up with the right answer in the first place. The maze analogy just makes this crystal clear, right? If I give you a completed path on a map, you can check it in seconds. But trying to find that path from the start, that could take you ages with all sorts of trial and error. That huge difference between verifying and generating, that's the key to this whole thing.
So this brings us to the core technology, energy-based models, or EBMs. The best way to think of an EBM is like an expert judge. It doesn't come up with answers itself. No, it looks at any possible answer and just gives it a score, which the researchers call energy. A good, plausible answer gets a low energy score. A bad, totally nonsensical answer gets a high one. It's kind of like a badness meter.
Okay, so how does this idea of a verifier get built into a whole new architecture, the energy-based transformer, or EBT? I mean, that's the big question, right? How does a model that only judges answers actually produce one?
Well, instead of spitting out an answer in one go, an EBT does something that looks a lot like actual thinking. It starts with a totally random guess. Then it uses its own built-in verifier to score that guess. Based on that score, it tweaks its guess just a little bit to make it better. It just keeps repeating this loop over and over, kind of asking itself, is this better? How about now? Until it finds the answer with the lowest possible energy score.
You can almost picture it, right? It's like a ball rolling around on this complex energy landscape. The model is just trying to find the lowest valley in that landscape because that absolute lowest point represents the best, most accurate solution. That's how it literally thinks its way to an answer.
So it's a really cool theory, but does it actually work? Does this new method really outperform what we already have? Well, the data they show in the paper is pretty convincing.
First off, let's talk about training efficiency. During that initial pre-training phase, these new energy-based transformers show up to a 35% higher scaling rate.
So what does that actually mean? It means they are way more data efficient, they learn faster and better from the exact same amount of information. And that is a huge deal when training these giant models costs millions and millions of dollars.
But what about the thinking part? Well, when the model is actually solving problems at what's called inference time, these EBTs can improve their own performance by up to 29%, just by thinking longer. And this is the crucial difference. A standard transformer, it doesn't get better if you give it more time. Its performance is just flat. But an EBT, by taking more of those refinement steps, by literally thinking longer, can use that extra compute time to find better answers, especially for problems it's never even seen before.
And the results in Vision are just as stunning.
So take a task like cleaning up a noisy image. This table shows EBTs get a higher performance score, that's what PSNR measures, than these super powerful diffusion transformers, or DITs, which are basically the champs at this stuff right now. And get this, they do it while using 99% less computation. That's not just a little better, it's a massive leap in efficiency.
So the main takeaway here is that this isn't just some small incremental improvement. This research might actually be pointing us toward a fundamentally new way of building AI altogether.
So let's just pull this all together. What this new EBT approach gives us is a path toward an AI that learns to think all by itself, just from raw data, no hand-holding needed. It works across different formats like text and images, it scales faster, it gets smarter with more time, but honestly, the biggest deal is that it can check its own work, and that's a crucial step towards building AI that we can actually trust.
This whole thing leaves us with a pretty provocative question. An AI that doesn't just give you an answer, but can actually improve and verify its own thoughts? That's a paradigm shift. So what kinds of problems could we finally solve with an AI that can truly think? Could it design new medicines, compose a symphony, maybe even help us understand the universe itself? That's the incredible future this research points toward.